Hello and welcome to Math Lessons with Linda. Today's topic is how to graph a quadratic, which in this case is going to be a parabola. Here's our function, y equals negative 2x squared minus 4x plus 6. So one of the things that you can quickly identify with a parabola is if it's going to open up or down, and that's with the a value. And when the a value is a negative, that tells you that your parabola is going to go downward, so it'll have a maximum point at the vertex. That's the first thing we want to find. What are the coordinates of the vertex? There is a shortcut that we can use to start us off, and that is x equals the opposite of b over 2a. Now that's just going to give us the x coordinate for the vertex, and then we can use that to substitute in and find the y value of our vertex. So recall that the a and the b and the c are just these constant values from your function. So to get x, I'm going to take the opposite of b. So the opposite, b is already negative 4. I'm going to put that in parentheses, over 2 times a, and a in this case is negative 2. So when I simplify with my signs, the opposite of negative 4 would be positive 4, and 2 times negative 2 is negative 4. So that means that the x value of my vertex is negative 1. So I've got that. I'm going to put the vertex, and I'm going to put negative 1 for x. So the next step is to substitute that into my original function and find the y value. So y equals negative 2 times negative 1 in parentheses squared minus 4 times negative 1 and then plus 6. So here I get negative 2 now times positive 1, because when I square a negative I get a positive. Negative 4 times negative 1 is a plus 4, and then my plus 6. So I have negative 2 here, plus 10. So y is equal to 8. So the y value of my vertex, I'm going to substitute down here, is 8. So I have my vertex, and that's one specific point that we would want. So another point that we would want is the y-intercept. So the y-intercept is where it crosses the y-axis. If we look at our original function, that c value is always your y-intercept, because if we substitute in 0 for these x's, those terms cancel out. So our y-intercept is 0, 6. That's a really easy point to find. So the last thing that we want to do is we want to find the x-intercepts. Sometimes there are 2. Sometimes you might just have 1. Sometimes there would be 0, and that would be imaginary numbers, which is a different kind of problem. So what I'm going to do to find the x-intercepts, and in this case, I already know there's a couple, so I'm going to make 2 points here. So to find the x-intercept, I'm going to let y equal 0. So in my original equation, I'm going to have 0 equals, and then my function. So it's easiest if you have a GCF for all of your terms. Let's go ahead and factor that out just to make the rest of our problem a little easier. So I'm going to factor out this negative 2. So that's going to flip all of the signs, right? So this now is a plus. 4 divided by the 2 is a 2x. And it's going to flip this sign, so I've got a negative 3, and 6 divided by 2 is 3. Okay, so this negative 2 now, I don't really need to use to find my intercepts. What I need to do is factor this trinomial. So I put x's in both spots, and then there's only one pair of factors for 3, which is 1 and 3. And I need the middle term here to be a positive, so I need my bigger factor to be the plus. And then I'll have minus 1. That makes all of my signs work out and my values. So I take each of these and I set them equal to 0, and then I solve So here I get -3, so I'll stick that up here for one of them, and then I get +1, so I'll stick that here. So I now have lots of different points that I can use to graph, and I'm going to do just a sketch for this. So I've got a pretty tall vertex, remember? And I'm going to make some values on my x-axis. So -1, 8. So -1 on the x, and then 1, 2, 3, 4, 5, 6, 7, 8, way up here. And then my y-intercept is at 0, 6. So 0, 6 is here. And then my x-intercept, so at -3 and +1. So now I'm just going to sketch them. Remember, our graph is going down because of that -a value. And here is my parabola completely graphed using all of my special values.